Now, the first thing I would like to go over is known as the golden ratio, also known as the rule of thirds, spiral rule. These are all essentially the same thing. Basically, nature, God, the universe likes to make things into thirds, halves, and patterns. In helping you understand how the terms golden ratio, rule of thirds, spiral rule are basically the same thing, I have 3 examples and explanations for you. The first one here is the rule of thirds. The rule of thirds is a pretty common photography and cinematography guideline. For the rule of thirds, it's pretty simple and straightforward. You just divide up your image into thirds, horizontally and vertically. Just like we have here on this picture of Dunkirk. Great movie, great cinematography. And I'm going to show you how this works and how you can use it in your paintings, photography, video. Sounds good? Let's go. So for this example, I'm going to start in the foreground and work my way back into the background. Make this red so you can see what I'm doing. So right off the bat, you might notice, okay, but there's this red line here, but this doesn't follow the red line. You'll notice this area and this area are almost the same. So we have right off the bat here in the foreground, we have a balance. And then if we kind of do a third section where we split up the thirds even more, we draw a line down the middle, not the middle, but the third, and another one on here. You'll notice that this silhouette is right smack dab in those thirds. You'll also notice that if I draw a top third here and a bottom third here, that's not equal. It's fine. That his feet are basically on this top third, on this bottom third, and his head hits the top third of this top third. So third section. You'll also notice that there's a third here, third there, same thing here. It's pretty much ending on that third. So there's a nice balance of start here, go there. If we follow this line all the way across, moving into the background now, we'll find that there's this edge of the ocean that pretty much follows that same line. If they had gone all the way across with this line, this makes your eye go right to that. So anytime you have lines doing this, it's an arrow for your brain. Your brain says, oh, look here. So what they did is they offset, they added some rocks to offset that. That's like so cool. It's so cool. Moving on, farther into the background, we have this guy. I don't know why he's here, but he's right on that third. And then if we draw a line on this third, boom, the cliff is right there and right on this third. So in talking about this background, so in talking about these thirds, this rule of thirds, it can also apply to silhouette and space makeup. So let's say in this one, if we were to outline this, this form, this silhouette here, takes up about a third of this space. If we move over to here, we'll see that it's almost the opposite. Now, I don't know if this is intentional or if it was just a side effect of it looking, the composition looking good. But this form takes up pretty much 2/3 of this part of the frame. So again, when you're doing rule of thirds, it can be either form makeup, it can be breaking down your image into thirds to help you get a better setup and breaking it down. We've got our balance here, so if you have something coming across at a diagonal, make sure that there's a nice sense of balance. And then on top of that, make sure that you have your composition works up if you break it down farther and farther. If we have this third and we break it down, we should be able to see that thirds happen more and more. And if we, right here on that third, there's this wave. So compositionally, this image is very well broken down into this this thirdception. So 1, balance with the rule of thirds. 2, no arrows. 3, form makeup. And follow this 1/3, 2/3 example. So we have a 1/3, 2/3. This in the middle is a third. And number 4, we have form. No, let's not do formception. Let's do third. 4, we have thirdception. So that's the rule of thirds example. Remember these. They will be important. So that's the rule of thirds example. Let's move on to the next one. Our next example will be the golden ratio. Right here. Golden ratio. This is known as 1.618, or if you want to use really smart words, two quantities ratio is the same as the ratio of their sum to the larger of two quantities. Now, I'm dumb and I don't understand what this is trying to say, but I understand the golden ratio. So let's get into that. If you understand this, congratulations, you're smarter than I am and you understand smart words. Basically, what this means, what all these smart words mean, is that this size, let's say this is like 5. Let's say this is 5, measurement of 5, and if we times this 5 by 1.618, we get the rest of this measurement to here. And then this whole measurement is 8. It's about 8. It's more like 8.09. But we'll just say it's 8. Right? About 8. That about is important because it's not exact all the time. And then if we divide this 5 by 1.618, we get something that looks like that. It's this big. And this can go on and on and on forever. It's an infinitely scalable measurement that fits together. An example here of this is here. So we've divided this amount by this number, this 1.618, and we've gotten this size. And then we do it again, we get this size. We do it again, we get this size. And it would go on and on and on and on and on and on and on forever. So keep this in mind because, again, this goes right back into our last example of the thirdception. Okay, so do you see how these are starting to fit together and work together? Okay, so let's move on to our next example. Our third and final example will be the golden spiral, or as I like to call it, the spiral rule. This spiral rule, or the golden spiral, builds on the golden ratio. And again, that third section that we talked about, it applies here as well. But instead of a linear line, we're cutting the line up and we're third septing the line. We're now using a box. And with this box, we're going to make a spiral that infinitely scales up or scales down perfectly. If we draw a point here in the middle, and then we draw another point about on this inner third. So again, if we third section this square, we draw a line on here, we draw a line on this third, and then we draw a curve. And if we repeat this all the way around to our next one, our next square, and we go, okay, draw another point in the middle of this square, and a line on this third here. Okay, eventually this square is this square divided by the golden ratio, 1.618. So this square, this square here is a third-ish smaller than this one. And if we keep rotating this around and around and around, we get something that looks like this. And if we keep going around and drawing a point in every square and dividing it up with those thirds in that third section, we get this golden spiral, this infinitely scalable spiral. And in nature, where we see this is plants, we see it in galaxies, and we see it in storms. It's everywhere. This infinitely scalable pattern, this third section, it's everywhere. And if we follow this, what we end up getting in nature is this. This shell follows the rule of thirds, the golden ratio, the spiral rule. It follows that perfectly. Almost over here. So the golden spiral is literally just the golden ratio plus the rule of thirds. Again, what I like to call it is thirdception applied to and added on top of a curve. That's all it is. And that is why I say these three things are essentially the same exact thing. There are so many other ways you can apply this. You can apply it to great design, cinematography, writing, music, animation, photography. The list goes on and on. This golden ratio, this rule of thirds, is all over the human body. It's literally everywhere. I'm super excited to show you this.